Hello everyone, in today's video we'll be analyzing employee satisfaction data. Our purpose is to generate a range of visualization to illustrate the distribution of each factor and the relationships between them. So our goal is to identify the key factors that impact employee satisfaction and understand why employees may choose to leave based on different factors. So let's start by importing our libraries. We are going to use Pandas as PD for loading data, Matplotlib.pplot as PLT for basic visualization, and Seaborn as CNS for statistical graphics. Next, we will load our data. We will use the code def equal pd.read csv. The name of my file is hdata.csv. Then we can use the sv.head to display the first few rows of the dataset, giving us a quick look at the data we will be working with. So over here we have satisfaction level of each employee's last evaluation, showing the most recent performance review score, and the number of projects each employee has worked on. We also have average monthly hours and the years spent at the company. Other columns include work accident left to show if they have left the company or not, and promotion last 5 years to indicate if they received a promotion in the past 5 years. Finally, we have a department and salary. To get the important information about our data, we can use the f.info. So this dataset contains 15,000 entries across 10 columns, with no missing values in any column. Next, we will use the function f.isNull.sum to check for any missing values. So the output shows that each column has 0 missing values. If it means we can proceed without needing to handle missing data. So to check the duplicate data, we can use the function def.duplicate. We have found 3,000 duplicate rows, so we need to clean them up. We will use the function f.drop duplicates to remove these duplicates. So after we do that, we will have 12,000 rows left. So now we get a cleaner dataset to work with. So next I'm going to give our dataset a new name, hrdev. So to take a look at the statistical summary of our data, we will use the describe function. This summary shows us a key value for each column, like the mean, minimum, and maximum. So starting with satisfaction level, the average is about 0.63, which suggests that most employees are generally satisfied. Last evaluation scores have a mean of 0.72, indicating most employees receive fairly high performance review, ranging from 0.36 to 1. Looking at number of projects, the typical employee handles about 4 projects, with some managing up to 7. Average monthly hours is around 200, but is ranged widely from 96 to 310, showing that some employees have much longer hours than others. For time spent at the company, we see a median of 3 years, but some have stayed up to 10 years, which may affect both satisfaction and performance. For work accidents have an average of 0.15, showing relatively few incidents overall. In terms of attrition, about 17% of employees have left, while promotion in the last 5 years is only around 1.7%, suggesting limited upward mobility. So this insight helps us identify potential influences on employee satisfaction and reasons for turnover. So let's move into the visualization. Based on these columns, for example, we can look into distribution of each variable to access overall their characteristic and trends. Also, the distribution of salary levers by department to compare departmental salary structures. The impact of each variable on employees living to identify factors contributing to employee turnover. Also, the number of projects by salary to examine project involvement based on salaries. And also the average monthly hour by number of projects and salary level. And finally, the correlation to evaluate relationship between numerical data variables. So let's start with the distribution of each variable, and I will create a histogram for each column. So I will start with a for loop to go through each column in each RDF. So for each column, I will begin by typing plt.figure, which set up the figure for our plot, and I will specify the size with fixed size equal 10.5. Next, I will use cns.histplot to create the histogram for each column, and I will pass in the column data from each RDF, and I will add a KDE equal true, which overlies a kernel density estimate, and also I will set the color to red. So for each histogram, I will add a title using plt.title, labeling it as the distribution of, followed by the column name. Finally, plt show, so to display each histogram before moving to the next column. The satisfaction level distribution shows a high concentration at both ends, with many employees either very satisfied or less satisfied. The last evaluation scores have a slight increase around the mid-range, but remain fairly spread out across different levels. The number of project distribution has clear peaks at specific counts, such as 3 and 4 projects. Average monthly hours show a broad range with a higher concentration around the 150 and 250 hours range, indicating most employees work within these hours. Time spent in the company has distinct peak at 2, 3, and 4 years, so showing that many employees have relatively short tenures. Regarding the work accident, we can see over here that the vast majority of employees have no work accident. The majority of employees have stayed with the company, with only a small portion leaving. Over here we can see that there is a limited upward mobility in this company. Because most employees have not received a promotion in the last 5 years. Certain departments like sales and technical have higher employee count compared to others. Regarding salaries, we can see over here that they are primarily concentrated at lower levels, so with few employees earning high salaries. So now let's set up a count plot to analyze the distribution of salary levels across different departments. So first I will start by typing penalty.figure to initialize our figure, setting the size to 10.5. Then I will use ns.count plot to create the plot. I'll set x equal department to display each department along the x-axis, and use hue equal salary, so to separate the bar by salary level. So I will also apply the color palette set number one. To help you explore more color options, I will include an image in the description with the name of various Python color palettes, so you can see all the options available for customizing your graphs. I will choose distribution of salary levels by department for the title, and finally I will use penalty show to display our count plot. Our graph shows that most departments have more employees in the low medium salary levels, with only a few in high range. In the management department, though, salaries are more balanced across low, medium, and high levels. Now let's create a scatter plot to explore the relationship between satisfaction levels and last evaluations. To start, I will use cns.scatterplot and set the x-axis to satisfaction level and the y-axis to last evaluation. I will also specify the data as hrdev. I'm setting the color to still blue. You can choose any other color, of course, and I include an image in the description with the name of various Python color. After that, I will add a title with palette.title, calling it satisfaction level with last evaluation. Lastly, I will use palette.show to display the scatter plot. The graph shows a significant clustering of points in the top right corner, indicate that as the satisfaction level increases, so does the last evaluation score, with most points falling between 0.5 and 1 in satisfaction levels and between 0.5 and 1 in the last evaluation. So this trend suggests that higher satisfaction is closely associated with improved evaluations. Now let's analyze the impact of each variable on employees leaving the company. We'll be looking at both numerical and categorical columns to see if certain factors influence whether employees stay or leave. Starting with the numerical columns, I will create box plot to observe the distribution of values for employees who stays versus those who leave. So I will start by setting up a list called numerical columns, which includes columns like satisfaction level, last evaluation, number of projects, average monthly hours, and time spent at the company. So these are the available we want to analyze. So using a for loop, I will go through each column in this list to create a box plot. For each one, I will use cns.boxplot and set x equal left to show the comparison between employees who stayed labeled as 0 and those who left labeled as 1. The y parameter will be set to the column we are currently analyzing, and I will also add equal left to show the two groups in different colors, and I will choose S1 for palette. I will set that equal false, ensuring that each box plot stays in its designated position. Each plot will have a title indicating the factor we are analyzing, which I will set using penalty.title. Lastly, I will label the x-axis as left 0 equal state, 1 equal left, and the y-axis which the column name to keep everything clear. I will display each box plot with the penalty.show before moving to the next column. So the first graph shows that employees who left the company generally had lower satisfaction levels compared to those who stayed, suggesting that job satisfaction may influence retention. In the second graph, we can see that employees who stayed generally had a last evaluation score around 0.7, suggesting higher scores may encourage rotation. Employees who left typically handled between 2 and 6 projects, showing a wider range of projects. In the fourth graph, employees who left generally had a wider range of average monthly hours, while those who stayed had a more consistent range, suggesting that extreme variations in work hours may be linked to higher turnover. For the last graph, employees who left show a broader range of years with the company, while those who stay have a more consistent range, indicating that a longer tenure may be associated with a higher likelihood of leaving. Maybe because employees who have been with the company for a long time may feel they are reached a point where growth opportunities are limited, leading to, example, a burnout, which can increase their likelihood to leave. So let's continue examining the impact of each variable on employees leaving, focusing now on categorical data. So I will create a list called categorical columns, which include department, salary, whether an employee was promoted in the last 5 years, and whether they experienced a work accident. Using a for loop, I will go through each column in categorical columns and create a count plot for each. I will begin by typing plt.figure and set the figure size to 10.5. Then I will use cns.countplot to visualize the count of employees who stayed and those who left within each category. And I will show the category along the x-axis, and I will use who equal left to separate the counts of employees who left versus those who stayed, with color coding applied using the set1 palette. Each count plot will have a title, which I will set with plt.title to indicate the impact of each specific column on rotation, and I will label the x-axis with the column name and the y-axis as count to make the data easy to interpret. Finally, I will use plt.show to display each count plot one at a time. In the first graph, employees in certain departments like sales and technical roles have higher count of people leaving compared to other departments, which is expected due to the initial distribution of employees across departments. In the second graph, employees with low or medium salaries show higher turnover, while high salary employees tend to stay. In the third one, we can see that employees who did not receive a promotion in the last 5 years are more likely to leave. And in the last graph, there is a slightly higher turnover rate around employees who experienced a work accident compared to those who did not. To examine the relationship between salary levels and number of project employees handled, I will start by setting up a violet plot, and I will use plt.figure, figure size equal 10.5. Next, I will create the violet plot with CNS violet plot. Then I will display salary level along the x-axis and the number of projects on the y-axis. I will use there equal HRDF and U equal salary to difference between salary levels, and I will choose set1 for color palette. To finish, I will add a title with plt.title, number of projects by salary, label the x-axis as salary and the y-axis as number of projects. Finally, I will use plt.show to display the plot. So we can see here that employees across all salary levels tend to handle a similar number of projects, with most having between 3 and 5 projects. So those high salary employees show a slightly narrow distribution, indicating less variation in project load compared to low salary levels. Now let's create a categorical plot to examine the relationship between the number of project employees are working on and their average monthly hours to understand how workload varies across different salary levels. First, I will using plt.figure fixed size equal 10.5 for the graph size. Then I will setting up the plot with sns.cutplot. For the x-axis, I will set x equal number project, display the number of project, and for the y-axis, I will use y equal average monthly hours to show, of course, the average hours worked each month. To differentiate the data point based on salary level, I will include equal salary in the function, and as usual I'm gonna using Seaborn palette for color. Finally, I will add a grid for clarity using plt.grid and display the plot with plt.show. So the graph shows that employees managing a higher number of projects, especially at the level of 6 and 7 projects, generally have higher average monthly hours, which reflect an increase in workload intensity as project count rise. However, when we look at the salary distribution by color, there is no direct link between salary level and the number of projects or average monthly hours. For instance, at 7 projects, we only see low and medium salary levels, red and blue point. With no high salary, the green point at this level. This suggests that a higher workload in terms of project and hours does not necessarily correspond with a higher salary. Now let's proceed with our correlation analysis by department. To start, I will print the data types of our data frame using print href.dtypes to understand the current format of each column and ensure that we have the appropriate data type for correlation. One crucial factor we need to consider in the salary column to analyze correlation effectively, it's important to convert this column into a numeric format. Categories, so low, medium, and high, which will be represented as 1, 2, and 3 respectively. Using the .log method, I will add a new column called salary numeric to our data frame. So this column will map the original salary values to their numerical equivalents using the dictionary salary mapping. And as we can see over here that the salary numeric columns added successfully. I will start by setting up a loop to iterate through each department in our dataset. For each department, I will filter the data to focus solely on the numeric columns using the .selectDataTypes method. So this ensures that we are only analyzing relevant numeric data when calculating the correlation matrix. Next, I'll calculate the correlation matrix for the filtered department data. To visualize the correlation, I will set the figure size to 10.8. Then I will use sns.heatmap to create the heatmap for each department. In the heatmap, I will enable annotations with the correlation coefficient using the _true to provide a more detailed view of the relationships. For the color palette, I choose cool warm, and I will also set fmt equal .2f to display the coefficient with 2 decimal places, and line weight equal 0.5 to add thin border between cells, making the heatmap easier to read. Lastly, I will title each heatmap according to the department being analyzed. So let's describe in a few of these heat maps to highlight the key relationship between different departments. In this department, there is strong negative correlation between satisfaction level and left minus 0.34, highlighting that dissatisfaction is a primary factor for turnover. Another notable relationship is the positive correlation between last evaluation and number of projects, 0.26, suggesting that higher evaluation may be linked to handling more projects. In the accounting department, average monthly hours has a moderate positive correlation with last evaluation, 0.29, indicating that employees working more hours tend to receive higher evaluations. Additionally, there is a positive correlation between number of projects and average monthly hour, 0.32, suggesting that handling more projects is associated with working more hours. In HR time spent at the company has a moderate positive correlation with last evaluation, 0.19, which could imply that employees with longer tenures receive better evaluations. Another significant relationship is the weak positive correlation between promotion in the last 5 years and salary numeric, 0.15. I think that recent promotion may be associated with a slight increase in salary. For the technical department, number of projects has a positive correlation with last evaluation, 0.26, indicating that handling more projects may be linked to better performance evolution. Additionally, average monthly hours shows a moderate positive correlation with time spent in the company, 0.23, suggesting that employees with longer tenures tend to work more hours on average. Thank you for watching, and let me know if you have any questions or if there is anything specific you would like to explore further.